Okay, there we go. So lateral area, we say is P times H, right? P being perimeter of a base, right? Okay. And most of the time, okay, unless it's this situation right there, most of the time the bases in a prism are going to be your non-rectangular surfaces. So in this case, our bases would be what? Triangles. Okay. And then H, what does H represent for lateral area? Good. We call it the altitude, but it is the distance between the bases. Okay. So when I go ahead and evaluate this and find out lateral area, your bases are, like I said, the non-rectangular surfaces. So would you agree that that triangle right there is your base? All right, what's its perimeter? 16. Okay, now the altitude would be the distance between the two bases. What's that distance going to be? 12. So 16 times 12 gives me what? 192? Oh. Oh, I made a mistake, Cam. 192. Okay. So 192, and that's centimeters squared, right? Okay. That's my lateral area. Now the sub-problem, that's what a sub-problem defining the surface area, right? Now I got to find out what capital B represents. Capital B is what type of shape? Triangle. So it's going to be 1/2 B times H. Okay. Now when I look at my base, okay, that distance right there is going to be H. That's 5. That's 5. This is an isosceles triangle, so what is that distance right there? That's going to be 3. So now, this is almost kind of another sub-problem. If I'm looking at that triangle, that right triangle is going to have an altitude of what? 4. Pythagorean theorem tells us that is 4. Okay? So then capital B over here is equal to 1/2 B. Okay? Lowercase b is the base length, right? What is that distance? 6. And then my altitude h, which is 4. Okay? So I multiply that stuff out, I get 12. Okay? So now, when I go surface area being LA plus 2B, you now know LA was 192, and you know B was 12. So I'll take 2 of those, and that multiplies together to be 24. Add to 192, I get 216. Okay? A lot of different sub-problems to generating that 216. Okay? Please don't just do stuff like this as you're going through these problems. Don't just do that. Okay? And maybe that. Okay? Because now trying to pick out the things that we need, are we going to be able to do that if this problem takes me 4, 5, 6 minutes? Am I going to remember what that 192 was with no labeling? Probably not, right? Okay? Label things, and it's easier to kind of grab them and use them the way you need to. Okay? Now, that one is, that's kind of a norm with rectangular, with prisms, okay, with right prisms, that once you find the bases, there's one and only one way of finding lateral area, and there's one and only one way of finding the base area. When we deal with the figure on the left, there's actually 3 different ways we can do that. Okay. Huh? Sorry. But I did record it. Okay, I just needed, was it? No, okay. 192 plus 2 times 12. All right, so on this one, surface area. is lateral area plus 2 bases, right? Okay. I'm going to find the lateral area first by allowing that to be a base. Okay. So that means that would be a base up top as well, right? So LA is P times H. What's the perimeter of this base on the bottom? 14. And now what is the altitude of the prism? 5. So 14 times 5 gives me 70, right? Okay. And what that 70 represents, guys, is that blue rectangle plus that blue rectangle facing you, plus this one over here on the left, plus then the one in the back, right? And that's a lot quicker to use P times H than to individually find those 4 areas and add them together, right? Okay. Now if I found surface area, so if I allowed those to be my bases, surface area would be 70 plus 2b. So I got to find out what capital B would be. What would you consider capital B here for these being my bases? It's a rectangle, right? So it's going to be BH. What are my B and H? 4 and 3, right? So it's going to be 12. Okay. So now when I go surface area, is LA plus 2 bases, where base is 12. Does that give me 94? Okay. Now, look at this tissue box. Let's say this tissue box is the box that the prism that we just dealt with up there. Okay? And the tops and the bottoms right now where my hands are would be those bases. Does that make sense? Does the surface, so this surface area right here would be 94. Does the surface area change at all when I do that? No. Does the lateral area change? Yes. Okay? Because if this here, that side, and that side, if those are my bases, my lateral area are these long rectangles, right? Okay? If I let the top and the bottom here now be my bases, then my lateral area is one long rectangle, a second long rectangle, and then 2 short ones, right? Okay? So the areas are redistributed a little bit. So let's see how that kind of impacts things as we choose different bases. So some people are going to say, well, I'm going to allow that side right there to be a base and that side right there to be a base. Okay? So if I did lateral area with that, okay, lateral area would be P times H. So perimeter of that base right there would be what? 5. That's 5. That's 3. And that's 3, right? It's got to be 16. Now, what would be the altitude between these 2 bases? 4. So we see when we multiply that out, we get 64, right? So we're seeing a lateral area that's 64. That's different than that lateral area, right? But let's see how the surface area then compensates for that. When I talk about capital B here, capital B would be the area of that thing, correct? Well, what's that? It's 15, isn't it? Okay. So now when I go surface area, it is 64 plus 2 times 15. Is that still 94? Which is the same as the surface area there, right? Okay. Now you could also do it one other way. You could say, I'm going to allow that to be my base. And if we do that, our lateral area is going to be, what, 18 times 3. There, the lateral area would be 54. Does that make sense, everybody? But the surface area, if I allow the front and the back to be bases, is still going to total to 90. Because there isn't a base 20. And then 2 times 20 will be 40. 54 times 40, or 54 plus 40 is still 94. So with rectangular prisms, and it's kind of the oddball, okay? Because you have options now, okay? That your lateral area, there could be 3 different lateral areas depending on what you chose for your bases. A lot of times, because that's the issue, in Math Excel, they might, one, tell you what the base is, have to be, or two, they might not even ask you to input what lateral area is. The overall question might just say, what's the surface area? Does that make sense? So those are kind of things to think about as you progress through that type of question. Is that all right? Yeah. Questions? We're good? All right. Take a minute and find that surface area. What do we, in order to find perimeter of the base, hopefully you'll have the triangle to be your base, right? What do you need to do to find the perimeter? Yep, and you use Pythagorean theorem, right? It's kind of a sub-question to this thing, and I need to be able to address that, be able to find perimeter. So your perimeter you came out with to be 12, right? And then you multiply that by 6 because h is the altitude of the prism, right? So you got 72. Awesome. Okay. So then the surface area is LA plus 2B's. So we got to figure out what a B is. And that's still this triangle here, right? So 1/2 of, what numbers do you use there? 3 and 4. Does it matter which one's which? Which one's the base? Which one's the height? No, because they're both altitudes in this case, right? Because it's a right triangle. So gives me base to be 6, correct? So surface area is going to be 72 plus 12, which is 84. And what's the units on this? Squared centimeters. What feet?
I was thinking feet.
So you got to pay attention. And this is something that Math Excel will do, and I will do, is that I'll give you 2 of the dimensions in centimeters, and the next one be in meters. So just make sure we're paying attention to those things. Paying attention to details is a big component to everything that you're going to do beyond this class. So, is that all right? Can we do that question? Fabulous. What about this question here? What kind of prism is this? Okay. So when I find lateral area, it's P times H, right? What is your base here? Hexagon. So the hexagon is going to have a perimeter of be 36, wouldn't it? That side 6. So then you got 6 of those sides, so 36. Now what's the altitude? 12. So that gives me 432. There's my lateral area. Now, that is the same as somebody saying, well, what if I take 6 times 12 and get 72 and multiply it by 6? Is that okay? So it gives me 432. Okay. My idea or my thought about P times H, it's because this is a regular polygon, is the reason why somebody could take 6 times 12 and then multiply that number by 6. If this was an irregular hexagon, so the side lengths were different, okay, you would not want to have to go through and find all 6 rectangles, because then the 6 rectangles would all be different. Does that make sense? But pH would still work for an irregular hexagon. Okay. Now, finding the area of the hexagon, if it's irregular, is a whole new process. Probably going to have to segment up into maybe rectangles and triangles. But here, if I want to find surface area, I need to know what capital B is, right? And capital B represents the area formula for a hexagon in this question. What's the area formula for a hexagon? Fantastic. Where A is your what? Apothem. Okay, so let me put a shape in here real quick. I just think it's a little bit easier to see the base with the kind of a two-dimensional view. So I'm going to look at this thing right here. I got to find that distance. I got to find the apothem. So what would that angle right there be? Or how do I find that angle?
Okay, so 360 divided by 6 will give me 60, right? And then you take half that. Okay, so that's going to be 30 degrees. Okay, so it provides me a 30, 60, 90 triangle. How big is that distance right there? 3. So now how big would my apothem be? Good, 3 radical 3, because it's across from the 60-degree angle, right? And that's the n radical 3 side in a special right triangle. So we go 1/2. Apothem is 3 radical 3. Perimeter is 36. Half of 36 becomes 18. What's 18 times 3? 54. So we have 54 radical 3 to be capital B. So when I find surface area, it's LA plus 2B's. So LA is 432. 2B's would be 108 radical 3. Great. Okay. And that's going to be meters squared. Can I add the 432 and the 108 and get 540? I cannot. Why not? Because they both don't have that radical 3 on it. Okay. They don't have a GCF that when I factor it out would leave me 2 real numbers to add together. Okay. Now the question there, I deleted it, but says find it as an exact value and then find it rounded to like the nearest whole number or something like that. And that's, I think, what some of your homework is going to ask you to do in Math Excel. Round to certain decimal places, whatever. My thought, and this is carried out throughout all math classes, if you have an exact approach, go through that. Find the exact answer, and then you can round that to any precision that you need to. Okay? Based off of how many decimals they ask. Is that something we can do? All right, here's a question that I have for you, and I think this is the reason why my computer was freezing earlier, so let's hope that doesn't do this again. But I'm going to take a figure here. Okay, I'm just going to take a polygon as my base. So that polygon. And basically the way I've got this set up is that it's just going to add sides to it as I move that slider, right? Okay. Now I've just tried to keep it so it's kind of relatively the same size. Does that make sense? So everything's kind of happening in between, you know, kind of that region of my grid. Is that right? By adding sides. So when I add sides, the 4 sides all kind of reduce from, in regards to their individual length. That's what they started with. Okay, so I'm going to take that shape as my base, and I want to look at it when I extrude it for a prism. Okay, so I'm going to take this thing, turn it into a prism. Height 5. Too big. Height 2. Too big. There we go. All right. Triangular prism, right? Surface area LA plus 2B, right? Okay. Rectangular prism. Surface area LA plus 2B, right? Hold on a second. Object properties. I had to go by ones. It's going by. All right, so rectangular prism, pentagonal prism, hexagonal prism, heptagonal prism, octagonal prism. Okay, and I can keep going, right? Now it's still a prism. But the more and more sides that I get, what is this shape over here? Even though it's still a prism, if I zoom in on it, it still has rectangular surfaces here as its lateral faces, okay? But as I start increasing the number of sides, okay? Kind of like what I explained at the beginning. Look at the lengths here of these sides. Let's see if I can find where they were over here. These are the lengths of the sides right now. 0.25. Okay, so that's that length right there, that length right there. As I start changing, it went to 0.2, 0.14, 0.11, okay? Eventually, that length is going to get so small, infinitely small, that the widths of these rectangles are infinitely small. Does that make sense? And when the lengths of the widths of those rectangles are infinitely small, what kind of shape do you have there? A cylinder. Okay? So that idea of making those widths infinitely small, that's one of the main concepts of calculus. But when we do that, it takes our prism and converts it over to a cylinder. So here's my question. If I'm at this stage right here, let's go right there, and I classify that with 33 sides, I can call that a prism maybe. And then once I go to 34 sides, maybe now we classify it as a cylinder. When I went from 33 to 34, did that shape change very much? No. So is the surface area going to change very much? No. Okay? So if that's the idea, if that's the concept, then that should tell us that the surface area for a cylinder is the exact same formula as the surface area for a prism. Okay? So we're going to kind of investigate this. I'm going to bring up another picture here for you. Close that out. Last class said they've seen kind of a demonstration like this, but trying to get you to view and realize that you have the ability, if you ever forget the formula for a cylinder, you have the ability to generate it pretty easily. The surface area for a cylinder is the same as the surface area for a prism. It's LA plus 2Bs. Okay? But when we think about what it was for a prism, LA was the sum of a bunch of rectangles, wasn't it? Okay? And capital B was the area of the bases. Well, if I look at a cylinder, what are my bases? Circles. So could I rewrite this as 2 pi r squared as 2b? And the reason we do that is because the cylinder is kind of like a special prism. So we can have a formula. If it's a triangular prism versus a pentagonal prism versus an octagonal prism, those formulas will change a little bit because the bases are changing. Okay? But if I have a cylinder, the formula for surface area of a cylinder is the same no matter how big or how small that cylinder is. Does that make sense? Okay? So we can have a specific formula for this. But now we got to figure out what LA is. Okay? And hopefully you've seen this before, but if not, the idea is that we can take the top off of our cylinder, take the bottom off of it. Okay, so now this blue kind of ring almost is like a toilet paper roll or a paper towel roll. Does that make sense? Or a pop can. You're taking the tops and bottoms off. Now we're going to slice that straight down. And when I slice it straight down, I want to make sure that it's perpendicular down here. Does that make sense? This is the altitude. That distance right there should be the same as this distance right here. And then what should I be able to create when I unfold that? A rectangle. That should be a rectangle right there. Okay? Now, would that be, can you view that as your lateral area? That makes sense? So my lateral area is now a rectangle, just like it was for prisms. For prisms, it was a series of, maybe 5 or 6 or 7 rectangles. Now it's just one. But I got to figure out, how do I find that area? Well, I know right now that distance is h. That's the altitude of the prism. But what would that distance be? The circumference of the circle. Okay? So lateral area is 2 pi RH. 2 pi r, because that's circumference, right? And then times h, okay,
that would give, so that 2 pi RH comes from the area of a rectangle. BH, where B is 2 pi R. Okay. Now remember, as you see that, R is the radius and H is the altitude of the cylinder. Okay. But if you ever forget that, because it is kind of it's a strange formula a little bit. Okay. If you ever forget that, hopefully that kind of introduction that I gave you and the fact that a prism evolves into a cylinder would help you remember that formula or generate that formula if you need to. So that being said, I'll do a couple problems here with a cylinder. And one of them, because we a lot of times are dealing with a radius, and because in that formula there's a lot of 2's, I like to write my values as fractions. I don't like to use, or improper fractions. I don't like to use that mixed number aspect here. Now, I'll just kind of explain to you why as we do the work. I'm going to rewrite this as 13 halves. Is that okay? What would my radius be? It'd be 2 inches, right? If I want to find surface area, that's going to be 2 pi RH plus 2 pi R squared, right? Now, when it says find lateral area, and there's 2 questions here maybe, know that the 2 pi RH is your lateral area, right? Huh? Yep, so the R is 2, so 2 pi times 2 times H. H is 13 over 2. And right there is the reason I like to write it as 13 over 2 instead of 6.5. Because what's going to happen with these 2's right here? They're going to cancel each other out. And then R squared would be 4, right? So those 2's are going to cancel. It's going to leave me 2 pi times 13, which is 26 pi, right? And then plus 2 pi times 4, which is 8 pi. So that gives me 34 pi inches squared. So as you're going through problems, guys, mixed numbers, again, are kind of useless algebra. Okay? Write them as improper fractions. And the reason for that is a lot of times, through the order of operations, those fractions dissolve themselves. They go away. Okay? Now, I want to do a problem that is very similar to some questions that you're going to see on your test for this chapter. Because I'm of the, you guys obviously know this, I'm of the mindset that you have already done, you know, questions like the one we just did. You did that in maybe 7th grade, 8th grade, whatever. Okay? Can we use some creative thought and be able to find the surface area of this bead? Okay? There's a lot of things kind of occurring here. Okay? So I want to find the surface area of this bead. Understand that there is it's a 3-dimensional shape, and to be a bead, there's got to be a hole in it, right? So when I cut that hole or drill that hole through that cylinder, I lose a little bit of area because I drilled it out, right? Does that make sense? But I also create some walls on the inside, don't I? So when I create those walls on the inside, does that add in some new area? So what I'm going to do, there's several problems here. I'm going to address this question initially as if there was a solid bead. There is absolutely no hole in this thing. Can I find the surface area of a cylinder with no hole? That would be 2 pi RH plus 2 pi R squared, right? What would R be in this case? Careful. Okay, and I'm going to write it as 9 over 2. What would H be for your prism? Be 20, right? Okay. Plus then 2 pi, your radius again, 9 over 2, 20 squared. Okay. Working through that, the 2 here and this 2 there cancel, right? Leaving me 180 pi. Plus then over here, 9 squared gives me 81. 2 squared gives me 4. So I get 180
pi plus, those are going to cancel, gives me 81 pi over 2. What do I need to add those two things together? Common denominator, so that becomes a 2, and this number up here is going to be 360, right? Is that still 180 pi right here? Okay, so the area of the surface area of the cylinder is 441 pi all over 2, right? Okay, now, if I drill a hole in this thing, and that hole right here is a square, if I drill that hole out, is that additive or subtractive? Subtractive. So you need to remove that hole, right? So the area of your hole, I didn't put an R in this in the last class, now I'll giggle. Okay. So area of the hole is going to be what? Square. Be 9, right? 3 times 3. Okay. Now think about this. So that's the area of kind of that base, right? Of that. When I drill through that, it removes that 9 from this cylinder, from this circle, right? Is it going to go all the way through? Yeah. So how much am I really removing? Careful. I'm just going to cut that hole out, and I lose area of that circle, right? So if I'm looking at this straight on, that circle right there, we know that area is inside this 441 pi over 2, right? We are now removing 9 from that, right? Is the other end of the cylinder going to be the same circle with the same square cut out? So area-wise, I've just removed 18 square millimeters. Does that make sense? Okay. So I'm going to remove 18 from that number right there. Okay. But when I drill that hole out, can I now kind of like shrink myself and walk through that bead? Are there walls? You touch those walls. It's that new surface area. So on the inside, think about this, on the inside there, when you drill out that hole, you now have that shape right there, right? And you're on the inside there. Okay? I can't touch the base here. This region here, this square, we have already removed, right? So it doesn't exist. Okay? But what would you call those walls for that prism? Lateral area of the prism, right? Okay? Can I find the lateral area? The lateral area of the prism by equaling perimeter times height? Altitude, perimeter times altitude. Now the basis would have to be these red ones. So what's that perimeter? 12. And now the altitude would be 20. So that'd be 240 new surface area that I can touch, right? So what am I going to do with that number with these two? I'm going to add it in. So now, can I add a negative 18 and 240 together? 441 pi over 2 plus 222, huh? There is the exact surface area, millimeters squared, of that bead. Okay? Which a manufacturer for mass producing these things, they would want to know that kind of stuff. Okay? In order to maybe purchase materials to paint it, purchase materials to make it, that kind of stuff. Does that make sense? Okay. Your test for this chapter is a lot of questions like that. Okay? Where I'm asking you to use pretty much the entire year in some creative thought to generate solutions. All right? Make sure last night's or Friday's homework is due for tomorrow.